Currently, the flat application is using async.io. So we're going to import async.io. So now we can wrap this in a async function. Stream olama response. And we can now make the, I guess I'll just move this up. Instead of with, it can be async with httpx. There is a async client in httpx. httpx.AsyncClient as client. This will be also async. The for loop will also be async. And we'll create a main function as well. So we'll go async def main. And we'll create a task for the stream, which will be a async IO. We'll create a task. It will be stream olama response, which is the async function that we just created. We'll await stream task if name equals main async io.run main. So this needs to be async iterate. So a iter, and we'll get rid of the OS clear for now. And instead of the OS, we'll use some ANSI code, escape code. So I'm going to print out here. So flush equals true with these ANSI escape codes. And we'll run it again and see what's happening here. Oh, perfect. Okay. Okay, appears to be working great here. But right now there's no difference between what we had before. So I'm going to attempt to simulate a button press. Simulate button presses. It's just a name that we're creating right now. And we'll go press count int equals 0. We'll have a try while true. We'll await the async IO sleep. So simulate button will be pressed every 0.2 seconds. And we'll print out a new line here. So \n, new line. Simulated button press. We'll have a number, which will be the press count. And we'll also have flush equals true. So it doesn't wait for the buffer. Except button simulation stopped. This will be async IO cancelled error. All right, so we have a simulated button press that we're going to attempt to put into the task queue here. So we have our stream task that's working. We'll now create the button task. Just asyncio dot create task, which will be our simulate button presses. So after the stream is done, we will cancel the button task. Button task. asyncio dot cancelled error, which will be pass. Okay, let's put the parentheses here, same as the top one, and let's increment the press count. By 1. Okay, we'll try to run it. And you can see that the button press is flashing every now and then. It appears briefly. Okay, congratulations. You finished adding the async capability to our simple command line application. To define an asynchronous function, it's async def. If you use await async on the function, await, it pauses execution within that function until the function that execution completes. asyncio.sleep will be non-blocking sleep, unlike time.sleep, which will block the entire program. You can schedule a coroutine to run concurrently with asyncio.create task. asyncio.run runs the top level async function. We used httpx, which is the alternative to requests. And httpx, this package, it has something called an async client that we just used. There's also, in addition to iterate lines, async iterate lines, which has the A in front of it. In our simple demonstration, we have the stream coming over, and even though the stream is coming over, it doesn't block the entire application. You can still do things or run it, and we're using a fake button press where we're just having something print to the console, but it shows you that even though the stream is still coming in, you can run another process or another thread in the background and have it to interact with the screen. Because it's a command line application, it wasn't as visually stimulating as a flat application, which we did earlier, but we did see the button presses, the messages would briefly flash to the screen, even though the LLM output was still coming in. Some other things that might be better would be a progress indicator, maybe have two different LLM requests going simultaneously. You could be reading or writing to the file or a file while the stream was coming in, making network requests to external APIs, or having a timer be displayed on the screen. So if you wanted to have a challenge to do the spinner, you'd create a list with the elements of the spinner, and then you use a loop to rotate it through the different elements of the list and delay it with asyncio.sleep by 0.1 seconds per iteration through the loop. Just to recap, the benefits of async is non-blocking. Other code can run while we're waiting for the I/O. This is more important if it's not a command line application or it's more obvious and it's a UI, because the UI will lock sometimes and you won't be able to do other things while the stream is coming in. It's a little tricky for many people, including myself, to use async I/O with Python because it was originally synchronous, and so there's a lot of packages. You can easily mix the async and async, and then it won't work because there's a blocking operation in the async code. There's problems with you got to remember to handle the cancellation. And even in this tutorial, I was originally using client. I was like, oh, I forgot to use the async client. But after you got to keep practicing, and eventually I think it will become a lot clearer and much easier. Hopefully you'll keep practicing with async capability on different types of Python applications, and join us in our Fast API class using FastOp, open source stack built on top of Fast API.